Okay, the second question review sheet, again, is just like that test you guys wrote, but hopefully a little bit different to make sure you've got the understanding and not just memorizing a question. So in this case, I've got a man jumping into some water. He's got a balloon, and he lets go of the balloon. Really, the object I care about here is not the man, but the balloon. I'm just going to draw it as a circle. I like to draw diagrams, you know this. So I've got a balloon, and it's below water because he's at the bottom, and he's released it. The first thing I want to do, because the question is, hey, what's the net force, is I want to draw all the force acting on this balloon. So I've got a buoyancy force that is right here, a buoyancy force of 10.0 newtons, so that's driving it upwards. I know that I've got a force of gravity acting down, even though it's a very small balloon, it still has some force of gravity. And then I know that it has a frictional force. Now, friction always resists the direction of motion. This balloon in the question already says that it's rising. Here it is where it says immediately floats towards the surface. Because I know the ball is traveling upwards, then I know that in addition to gravity, I also have the force of friction resisting the direction of travel. The force of friction I can already label. I believe it's here, right? So I've got 5.0 newtons of force acting downwards, but the question is the net force. To get my net force, I've got to figure out the force of gravity. The easiest way to do that is force of gravity is going to be my mass times acceleration due to Earth. We assume we're in a swimming pool on Earth. Now, before I just drop in my mass, because it's right here, mass of 10 grams, what do I have to do? Right, I've got to convert that into kilograms, right? So I need to divide my grams by 1,000 because there are 1,000 grams in a kilogram. I'm not going to show that quick because I want to do this fast. So that's going to be 0.01 kilograms multiplied by the acceleration due to gravity, 9.81. I'll just bang that into the calculator and we'll see what we get. 0.01 times 9.81. And I'm going to get a pretty small force here, 0.0981. Oh, I guess I could have seen that, of Newton's force. Okay. So I've got a force of gravity now. I can just use it right here, acting here. But how do I put this together as a net force? Well, net force is the sum of all your forces. But let's define up as positive and down as negative. Remember, that's not always the case, but here I've clearly defined it. So I can put this together to say, you know what, my net force is just the sum of all the forces acting on my balloon. So I've got my buoyancy force of 10 newtons, and then I've got my force of friction of 5 newtons, and I've got my force of gravity, whoops, wrote gravity, force of gravity, it's very small, 0.0981 acting downwards. I'm going to put those into my calculator, so 0.0981, and very close to 5, I'm going to get 4.9019 newtons of force. It's a positive number, so I defined up as positive, so I know I'm going up. Not my final answer, though. I'm going to look for my least significant. Looks like I got 3 digits all the way around. So my final answer in significant digits will simply be 4.90 newtons of force up. Notice how you have to indicate a direction, or you guess you could assume positive, but I really like writing up in this case.